Okay, so for the following circuit here, we're told that the voltage loop gain is 2 times 10 to the power 5. The input resistance is 2 mega ohms, and the output resistance is 50 ohms. And the op amp is used in this following circuit here. And we have to find the closed loop gain and find I when Vs is 2 volts. So we'll just replace Vs with 2 volts here. And so we got an op amp here, so pretty much we can redraw this circuit based on the circuit that's equivalent to an op amp. So think of it like this way: inside an op amp, there is the this mini circuit here. Okay, so this is the input resistance. This is the output resistance. Then there is a voltage called VD here. Its polarity is based on the sign here, so it'll be plus here, minus here. Then there is a dependent voltage source. Its polarity is opposite to this, so the plus will be here, the minus will be here, and it's equal to, and it's A times VD, A being the voltage gain. Okay, so we can pretty much put this, put the circuit inside here and put it here instead. So we'll pretty much redraw the circuit into something like this. Okay, so we can pretty much redraw the circuit in this way. Notice how this portion came from here, okay? And this is VD, which will be the input, sorry, so hold on, let me do it again. VD is here, and the resistance at VD will be the input resistance, which is 2 mega ohms, which is pretty much 2 million ohms, okay? Then we have AVD here, A being 2 times 10 to the power 5 VD. Then here at this resistor is our output resistance, which is 50 ohms. Alright, and we need to find VO over VS, and we have to solve for I. Okay, I being the current passing through here. Alright, oh yeah, then there should we can connect this to here. There we go. Okay, so let's set this to be VA, and let's set this to be VB. Okay, so we'll have a current passing through here. Let's call this I1, I2. This one will just be I. And for this one, there will be only this current passing, because since this is an open wire, the current passing through here will be 0. Alright, so for node VA, I1 and I2 are leaving, as well as I. Okay, and this is all equal to 0. I1 will be VA minus 2 all over 10,000 ohms plus VA minus 0 all over 2 million ohms. Okay, plus VA minus VB all over 20,000 ohms. Now for node VB, I1 enters the node, and this will be equal to let's call this I3. Sorry, I also call this I. My bad. It should be. Let's call it I3. And this will be equal to I3, which is leaving. So I1, it's VA minus VB all over 20,000, and this is equal to I3, which will be VB minus. So the voltage here will pretty much be the voltage here, which is 2 times 10 to the power of 5 VD all over 50 ohms. Now let's find a way to substitute something for VD. So let's see what we can do. We see VD is located here, and so that means, and we see the polarity is in this way. So we see as, hold on, sorry, everything's erasing. Give me a sec. As VA, as the current travels through VD, it leaves from the positive terminal. Okay, so that means there is a voltage increase. Okay, so it'll be VA plus VD equals 0. So that means VA will be equal to minus VD, or VD will be equal to minus VA. Okay, so we'll substitute that in here. There we go. So this turns into positive, and this will just be VA. Okay, and we also notice that VO will be equal to VB, because the VO will be the voltage. Hold on, sorry, my pen keeps dying. The voltage across this wire. Okay, so let's solve for that. And oh yeah, and then VS is pretty much just 2, because that's what it said in the question. So let's isolate for 1. So let's break this all up. So it'll be VA over 10,000 minus 2 over 10,000 plus VA over 2 million plus VA over 2,000. Let's bring the VB to the other side. Okay, let's try and isolate for VA. Okay, then we can substitute VA into here and then solve for VB. So VA will be 1 over 1,000 plus 1 over 2 million plus 1 over 20,000. So that gives me 1.505 times 10 to the power of minus 4 VA minus, so 2 over 10,000. So that's 2 times 10 to the power of minus 4 equals VB over 20,000. Let me bring this to the other side and divide both sides by this value. So it'll be VB over 20,000 minus 2 times 10 to, sorry, it'll be plus because the sign changes. Alright, and now let's solve for VA. So VB is 1 over 20,000, which is 5 times 10 to the power of minus 5, divided by 1.505 times 10 to the minus 4. That's 0.33222 VB. Then 2 times 10 to the power of minus 4 divided by 1.505 times 10 to the minus 4. That's 1.3289. Okay, now let's focus on this one. So VA over 20,000 minus VB over 20,000 equals VB over 50 plus 2 times 10 to the power of 5 VA over 50. Let me erase this. There. Okay, there you go. So VA will be put into here. hold on. Actually, I think it's best to quickly add this VA with this VA, because then I don't have to do two separate calculations. So let me actually simplify this quickly. So I'll bring this to the other side and bring this to the other side. So it'll be 1 over 20,000 minus 2 times 10 to the power 5 divided by 50. And that gives me minus 3,999.99 VA equals 1 over 50 plus 1 over 20,000. And that's 0.02005 VB. Now let's plug in for VA. Okay, and then let's FOIL everything in. So it'll be minus 1328.87 VB minus 5,315.58 equals 0.02005 VB. And let's solve for VB. So bring this here, bring that here. So minus 1328.89 VB equals 5315.58. VB will be equal to minus 4.0000, wait, yeah, 00149. So that's good. And that's what VO is equal to. Wait, was there 5 O's? No, 4 O's. Yeah, okay, good. And then VO over VS, so this is divided by 2. That gives me minus 2.000000745. Okay. Now they want us to find the current, which is this current. So we see that will be equal to, from here, we see it will be equal to VA minus VB all over 20,000 ohms. So let's solve for VA quickly. VA will be, so let's just plug in VA, so 0.33222 times minus 4.0000149 plus 1.3289. So that's, hold on, sorry, my pen keeps dying. Okay, that's 1.50499 times 10 to the power of minus 5 volts. So minus 4.000. I'll just do minus 4 all over 20,000. Okay, and that gives me 2 times 10 to the power of minus 4 amps. So that's your value for I.